Okay, so today is 9/19/18. So they like to call it special products. There's really not anything that's special about it. If it's a plus 3, it's a plus 3, we can just go a plus 3 times a plus 3, okay? And it's exactly what we did yesterday. Now I will, just for the heck of it, show you their little trick, the book's little trick, but anyway, it's just the same stuff we've done before. A squared plus 3a, right, plus another 3a plus 9, right? Right? We're going to do the double distribute, or call it FOIL, whatever you want to call it, right? Call it whatever you want. Middle two terms becomes an a squared plus a 6a plus 9. Okay, now that's pretty easy, isn't it?
That's easy.
Now the book tries to show you a fancy way to do it. They'll go and say that it's just this squared, a times b, but double it, and b squared. So they'll say, you can do this in your head if you wanted to. You can go a squared and b squared, we know that. And the middle term is going to be that times that, but 2 of them. Let me show you how that works, okay? So it's just a kind of a same thing. So if you go a squared, so if I did a squared and a 3 squared, right? And a times 3 is 3a, but double it and you get 6a. Okay, that's just another way to do it. But you know what? If you don't care about that way, just do it the other way. FOIL it, right? Just
I think it looks nicer. Wait.
Yeah.
What did we find? Like what did we accomplish?
What we accomplished was this, Landon. Quantity squared means it's really times itself, right? It's times itself.
But can't it just be left as?
It can. Yeah, it can. It can be left as the original problem, right? Because you might debate that that's a nicer answer than that.
We just made it bigger.
We have made it bigger, but there's some problems where we need to make it bigger to do some things with it. Does that make sense? And we'll see those problems later, okay? All right, so let's look at 4. Okay, so for me personally, I think it's much easier just to, negative 2x plus 1, negative 2x plus 1. Their rule would be positive 4x squared, 1, I'd get a negative 2x, I'd get a negative 4x. So if you want to do it in your head, you can. I'm just going to do it the long way, okay? And some of you saw the other way. It's fine. So let's FOIL it. That times that is a positive 4x squared, right? Negative times a negative is a positive. We'll get a negative 2x. I'll get another negative 2x. And I'll get a positive 1, right? And then we just combine the middle two terms, right? We get a 4x squared minus a 4x plus 1.
Wait. Negative 4.
Yeah. Everybody okay with that? Yes. Their trick would be square this, you get a positive 4x squared. Square that, you get a positive 1. Multiply that times that and double it. Okay? But you don't have to do their trick. Yeah, Hannah? Yeah, you want to do number 2? Sure. So number 2, I'm going to go b minus 2 times another b minus 2, okay? And we're going to get a b squared, right? Minus a 2b minus another 2b plus 4, right? And then the two middle terms we can combine and go b squared minus 4b plus 4. Okay, now their trick, the book would say square that, that's b squared. Square that, you get a positive 4. b times negative 2, negative 2b, and double it. That's their trick. I don't care if you use a trick, as long as you can just get it, okay? All right, now, let's go down to 7, okay? 7's a little bit more complicated, but still the same thing, okay? Let's go down to 7. So I'm going to write my 3x plus 2y times a 3x plus 2y, right? And we'll go ahead and FOIL it like we've always done. We'll get a 9x squared plus a 6xy, okay? And I'll wait for you to catch up. 6xy, right? Now this is going to give me a 6yx, but that's the same thing. Okay, this will give me a 6yx, but that's the same thing as a 6xy, right? Because the order doesn't matter when you multiply. When you multiply, the order doesn't matter. And then a positive 4y squared. Okay, and then I'm just going to combine the two middle terms, right? We're going to get a 9x squared minus a 12xy plus a 4y squared. Okay? Right.
Well, hold on.
I will.
It's not in order.
You know, it is in order. Very good point. It is in order because they all have, in a sense, equal degrees, don't they? 2, 2, and 2, right? But you know, Caleb, in this case, you could rearrange them. You could. And nobody would be able to argue wrong against that because you'd be completely right. You could, I mean, because they're all equal terms, right? It's just, you know, since the x squareds came first and the y squareds come last, we normally write it like that. But you'd be completely correct to rearrange them, okay? Good question. Now, 10. They call this difference. Difference of squares. And you'll see why. We'll call it difference of squares. And, oops, can you see that? Difference of squares. They'll call this difference of squares. And these are the same thing, except our middle term will disappear. But let me show you why. Our middle term, so we get x times x squared, right? X times 3 is a positive 3x, right? You can't see it, sorry. Negative 3 times x is a negative 3x. And a negative times a positive is a negative. A negative times a positive is a negative 9. But what you're going to see on these is the middle terms will disappear, right? And cancel each other out. Yeah, totally right. And then you'll get an x squared minus 9. They call it difference of squared because that's a square number. That's a square number, and that's a square number. In fact, that's 3 squared, right? Okay, so these are no different than things we've done before, right? Absolutely, okay? So how's that? Thumbs up on today's lesson? Do I need to do any more? No. I didn't think so. I don't want to waste your time. Let me stop the recording, okay?